Hey everyone, welcome back to Coursera. Today we are again back with another problem solving question. So today is day 37 of our level up series, and today we will be solving one of the lead code question which will be based on recursion and backtracking. But we are not deep diving into recursion and backtracking as we are just following on in our series. So today's question is of generate parentheses, one of the classical problems on lead code. So now let's get into it and see how we can solve it out. Although I doesn't know what sort of code in this image is written and why this man is like what this man is coding right now because language is non-understandable. I think it is in Chinese. He is coding in Chinese. So now let's get into the question and see how we can solve it out. So question is quite simple, but still we will be doing our classic way of taking screenshot, going in OneNote, solving it out there, trying to find out method with which we can solve it in most possible. Here we are so placing the screenshot, generate parentheses. Here we are. Okay, so now let's get into the problem. So problem statement is quite simple. Generate parentheses. You will be given n pair of parentheses, and we have to write a function to generate all combination of parentheses in this. What does it mean is they will be giving us input of three. So it means three pair of parentheses. And what do I mean by three pair means in total six brackets will be there in each of them, and it's not like we have to generate how many number of parentheses. It is similar way. It is just like we have to create a series of parentheses. So in each of the string, we can say where they have given the output, there should be three pair of parentheses, and three pair of parentheses means six brackets in total we need in a single one. So if they are given input of 3, it means in each of these strings which we have written, it will be like 1, 2, 3, 4, 5, 6. Now they are 3 pair of parentheses. Again, if you try to make a combination, it will be like this, this. There will be another one, this will be like this, and then this. Oh, sorry, this. In this way, actually the parentheses will be working off. Now we have to generate all these parentheses here in front of us. So what can be the possible way? Now there are a few things which we have to keep in mind. With the number that they are giving. If they are giving n equals to 3, it means 3 pair of parentheses, and 3 pair generally means into n, it means not n into 1, basically n into 2, because one pair have two brackets, one is opening, one is closing bracket. So it will be like 3 into 2, and it means 6 brackets in total we need in a single string. 6 in single string. 6 with needed in a single string, and along with that, we should always keep in mind when we are making these brackets, and whenever we are making these brackets, it should not exceed the closing brackets more than the opening one. So it is like I can't at a point I can't make something like this because this will be invalid parenthesis. If I want to complete this, one opening bracket is already there. Even if I place two brackets here, then also it is not a valid parenthesis because valid parenthesis should be in balance mode. It is like we need to ensure our opening brackets must always be, and let me write this off, our opening brackets must be greater or equals to the closing ones. Okay, so we can make it like this, and then this, and then this. But we can't do it like this. There's right now only one opening bracket and making two closing brackets. This should not be the condition because then it will become an invalid parenthesis. And what do I mean by balance? And imbalance means uh, for it is like for every opening there should be a closing one also. So for every opening bracket, there should be a closing bracket. Now let's think about how we can solve it out. What can be the approach? Now, if the brackets need to be placed, we can follow the recursive approach, backtracking, going to the end, finding out the solution, pushing it back, and solving it out. So for this, what sort of approach I can tell you is, now let's get into the approach only. Now, if I have to tell you, there should be a function named as recursive function. It should have a answer. Answer should be like of vector type string so that we can push the strings which we will make of the brackets. There will be a left pointer. There will be a right pointer. There will be the n, which is basically the size which will be given as input, and a word we can say or a string which we have, which we will be making up basically. So word. Now let's see what we can do. First of all, there will be a condition which we have to write. This condition in recursive function is for sure important because without it, it will go to infinite. So it will be like if in a case our word's size, our word dot size becomes equals to n into 2, in that case we have to do something. So we will be making of the word of those strings or those brackets. So we have to get into size which will be equals to n into 2. And n into 2 means the number of pair we have or we want in a string. So it will be like when we reach this base condition, at that time we will be returning off and let's name this function as word only. And in the answer, we will push back we will be pushing back our word. So it will be like we will be pushing back our word again and again while doing the recursive approach. And then we should write a case if our nth or if our left or we can say left will be for the opening brackets, the right will be for the closing brackets. So it will be like if our left should be always lesser than n, left should be always lesser than n, and then we will again call this recursive function in which we will write the values as same as earlier. But in the word, we will just add opening bracket and increase our left pointer also here. Similarly, we will be writing another if condition, which will be right less than left. So right left less than left. What does it mean actually? Is our left pointer will be there, and what we want is our right pointer will be pointing towards the closing brackets, as I mentioned. So it will be for closing, and this is for opening. And as I said, I should make a condition in which our closing bracket should always be lesser than our opening brackets. So it will be done in this way only. We will always keep a track even if the recursion is happening. Our opening bracket should always be greater than our closing brackets. So it is like if we will go for the recur, now again we'll be writing the same thing. But now left will be getting increased means one more closing bracket is placed. Left plus one, it means plus one in the opening brackets, and right plus one is means plus one in the closing bracket. And then in the word, we will be adding of a closing brackets, and then that's how we can sort it out basically. So now let's see how we can solve this out on LeetCode. So here we are, generate parentheses. Here's the function already given to us. Let me make a vector type of string, and that is as answer. And let's make a function as recur. So now let's see how this recur will work. So first of all, as I have told you, recur will be a void function. So I will be making it void only, void, and it will be recur. And what sort of things it will be taking off is vector type of string, and this string also is of answer. naming it as answer, but we will be passing it as a reference. So it means the AND operator will be applied here. Now, there will be another thing which will be int left, which I told you int right. Opening and closing, we can name it as, but left and right pointers, we are more functional, we are more happier with these values. So that's why I'm getting left and right. Along with that, int n, which will be the size basically, and there I need a word also, string word. Okay, now let's write the condition if word dot size reaches somehow till our n into 2. In that case, we have to push back the word into our answer dot push back our word into our answer, and then we can return up simply because this is a void function, so we don't need to return any specific thing, but it should be returned in here only. So this will be our base case uh, when we have return of the word and then get rid of it. Now let's add the other conditions which I mentioned. Now if our left is still lesser than our m, in that case let's call the recursive function again. Recursive function. Answer will be same. Okay. Left will get increased. Left is basically our opening bracket, you can name it as left plus 1. Right will be similar because we didn't added any closing brackets. After that, n will be similar. But in our word, we need to add one thing. We need to add an opening bracket. Just these things. Now, another condition which we need to match is for our right, it should be lesser than our left, and then doing the recursive call again. Answer left. Now left will be staying same only. Okay, but for the right, it will be plus one, and obviously n will not be changed. And word in the word we will be adding a closing brackets. So it will be like this, and that's all I think so. Yeah. Now, in the recursive function, we need to pass off the values. Answer is the first thing we are passing off. Second thing is the left and right. Left and right in the starting it will be zero only. There are zero opening bracket, zero closing brackets. There will be an n which we have to pass on. There will be an empty string which we are passing. Then at the end we are returning off the answer. And here we go. Now let's see how it will work. It got accepted. So we are able to submit the uh, question also. Let's see if it happens or not. It got accepted also. It is running perfectly fine. We have used recursion. That's why the time from next we are getting it in exponential 2 to the power n. Okay. Submitting it again. If there is anything else, I can check it off. So that's how it is working absolutely fine for this specific problem. We have to generate parentheses. We have used recursion, backtracking. You didn't get that glimpse of extreme recursion of backtracking here, but for the basic ones, it is quite nice. So I will be pasting the question link. You can go check out, try to solve it, and that's all. We are done with this problem. So we are done. Thanks for watching. I hope you like it. I hope you will solve this also. So thank you guys.